Oh, hey, Chem 20s. I think this is started now. Um, just going to put together a few videos here for some stoichiometry practice for you guys on your week off. You guys can kind of, if you want to follow along with me and do this, you can work on a question sort of together here. I'm going to look at number 38 in your workbook here. Which is a gravimetric stoichiometry question. So anytime you're talking about gravimetric stoichiometry, you're talking about, I should get my pen here. You're talking about mass, and anytime you're dealing with mass, you're gonna be talking about getting some molar mass. So these are actually kind of the most tedious questions in terms of stoichiometry, because you have to calculate your molar mass and you have to make sure you're doing it correctly. Otherwise, you're going to be in trouble. For your conversion factors for these questions, right, you're always going to be dealing with, X amount of grams per mole, or, X amount of grams per mole, like that. So let's look at this question. So we have questions asking how many grams of potassium permanganate will react with 36 grams of iron 3 hydroxide. So we want to find out exactly how many grams of potassium permanganate we're going to need to react all of the 36 grams of iron 3 hydroxide in this chemical reaction. Now, of course, with any stoichiometry, the first thing you need is that reaction, a balanced chemical equation. So let's start that out. So if you guys are doing this along with me, this is where maybe I'd pause the video, and I want to see if you guys can come up with that balanced chemical reaction on your own. So do that now. Okay. This is how I would write out the balanced chemical equation. I'm looking at potassium. I'm going to use my periodic table. So potassium is a 1+. I have to go find permanganate. This is one that we don't see too often in Chem 20. It's a polyatomic ion. It is MnO4 with a negative charge. Iron 3 and hydroxide. Okay, so now I can use those ions to build my ionic compounds here in this problem. So I'm going to have KMnO4. We're going to assume solid for that, since it's an ionic compound. And we're going to have iron 3 hydroxide. So we're going to have Fe, and then we're going to need 3 hydroxides there. Now this is going to give us, we'll assume solid there as well. So this is going to give us a double replacement reaction. So I'm just going to swap my anions here. So my potassium is going to end up going with my hydroxide. So I'm just going to get KOH, because each of those is a 1 charge. And I'm also going to get iron 3 permanganate. So it's going to look like this: Fe MnO4. That's a polyatomic ion. I'm going to need multiple of them because they're only a 1 charge, and I need to match up with my irons 3. So I'm going to need 3 of those. Okay, and these are all ionic compounds. We're not told it's in solution. We're just going to assume solid. Now the last thing, of course, I need to do is balance this. I'm going to go look for my my highest subscript numbers and sort of go from there. So I have 3 MnO4s here on my product side. I'm going to need 3 of those, and then I'm going to follow up with my potassium. Now I have 3 potassiums on the reactants. I'm going to need 3 potassiums over here. That balances out my 3 hydroxides, and now I also have I have 1 iron. Yeah, I'm good. Okay, so we're good. So I have 1 iron on each side. Okay, so we're balanced now. So the next thing I'm going to do is write down my given information and figure out what's my given and what's my required. So how many grams of potassium permanganate am I going to need? So I don't know how many grams of that I'm going to need. That's my required. My given information is that I have 36.00 grams of iron 3 hydroxide. So that's my starting point for this. That's my, this is my given. That's always where I'm going to start out. And you never want to start out with a rate or a conversion factor as your unit. You want to start out with something that has, just a single measurement, a single unit. And so in this case, I'm going to start out with that 36 grams. So 36 0.00 grams of my FeOH3, and I need to convert that to moles. So I need to get that into moles. And how do I do that? Well, I'm going to need the molar mass. So the molar mass of FeOH3, I calculated it before here. So I'm going to turn on my calculator here. Shout out to Grinder for my TI-84 Plus Silver Edition here. And so my iron 3 hydroxide is my second one that I calculated here. So it's 106.88 grams per mole. So 106.88 grams per mole of this FeOH3. I should have my... I'm trying to write on this like vertical, so my writing's kind of messy here. But I think you guys kind of got the idea there. So now I'm converting my grams of that substance into moles using the molar mass. Okay. Now we're going to do stoichiometry. What we're going to use is we're going to use the balanced chemical equation and the coefficients in order to jump from one substance to another. So my required chemical, there's 3 moles of it. 3 moles of KMnO4 for every 1 mole of my FeOH3. And so moles of FeOH3 are going to cancel, and I'm going to have now I've converted to moles of my required chemical, my potassium permanganate. So my last thing, now I have, if I do all this math, I'm going to have moles of KMnO4, but my question's not asking for moles, it's asking for mass. So this is a 3-step stoichiometry problem. It's a three conversions here. So my last thing I need to do is I need to go from moles of KMnO4 into grams, okay, because I want grams, right? And so again, that's going to be a molar mass. So I calculated that molar mass before. It's 158.04 grams for every 1 mole. And so my moles of KMnO4 are gone. Now I'm ended up with grams, and I can put my KMnO4 in there. And so that's my unit that I've ended up with. So let's do the math and see how everything worked out for us here. So we're going to take our 36.00 grams. We're going to multiply that by 1 over 106.88. Okay, we're going to multiply that by 3 over 1. And there's multiple different ways you guys can put this into your calculator. You could break it up into 3 steps. You could use dividing instead of multiplying by, the fraction. All kinds of different things that we could do. The last step I'm going to do is multiply this by my 158.04. And hopefully I get the right answer. Otherwise, I'm going to have to make a whole new video, which is going to suck. But I'm pretty confident here. So let's see how we did. I got 159.69. which is going to round to 159.7 grams of my KMnO4. And there you have it. So, that one has, that's kind of the most difficult gravimetric stoichiometry problems that we might see. So hopefully you guys, could kind of pause the video throughout here and be able to do that with me. And I'm going to post a couple more of these for the other types of stoichiometry over the next little bit. Good luck, and let me know if you have any questions.